Today we will be discussing Chapter 10 in your Health Statistics book. Descriptive statistics are used to describe data in ways that are manageable and easily understood. In this chapter, we will be discussing the basic concepts of rank, quartile, decile, percentile, measures of central tendency, including mean, median, and mode, as well as measures of variation. Before studying measures in descriptive statistics, we are going to briefly cover two concepts. The first is variable. A variable is a characteristic that can have different values. For example, a person may be HIV negative or positive. The characteristic or that variable is HIV status, and the values are then negative and positive. Because it is difficult to draw conclusions from data that is in raw form, they often summarize that into frequency distributions. A frequency distribution shows the values that a variable can take and the number of observations associated with each value. Using the previous example, a facility conducting HIV testing may be interested in the number or frequency of HIV negative and positive individuals using their services. Rank denotes a value's position in a group relative to other values organized in order of magnitude. For example, a rank of 50 means that a value or score is 50th from the beginning or from the end of a series. The number of scores in a sequence is important in determining the significance of a rank. If there are only 60 scores, for example, a rank of 50th is interpreted very differently than if there had been 1,000 scores. In ranked data, the position of the observation is more important than the number associated with it. In addition to determining the rank of the score in a group, it can also be helpful to divide data into parts to better understand the relationship among the scores. Data organized in order of magnitude can be divided into 4 equal parts or quartiles. The first quartile corresponds to the 25th percentile and includes the first 25% of data. The second quartile corresponds to the 50th percentile and includes 50% of data, and so on. Deciles represent data divided into 10 equal parts. The first decile corresponds to the 10th percent and includes the first 10% of scores. The second includes the 20th, and so on. As quartiles divide scores into 4 equal parts and deciles into 10, percentiles separate the scores into 100 equal parts. If a person scores at the 54th percentile, his score is greater than or equal to 54% of all scores in the group. This is called a percentile rank. In summarizing data, it's often useful to have a single number that is representative of the entire collection of data or specific population. Such numbers are customarily referred to as measures of central tendency. A common measure of central tendency is average or mean. It is the sum of a set of numbers divided by the number of data points. There are three measures of central tendency that are used most frequently and that we will discuss in this lecture: mean, median, and mode. The mean is the arithmetic average. It is common to use the term average to designate mean. It is computed by dividing the sum of all scores by the total scores. So the example on your slide here, we have 7 hospital inpatients with the length of stays listed. We would order them in the frequency distribution, and then we can sum and get our mean. So after we sum all values in that frequency distribution, we can divide by the frequency, or how many values are there. In this case, we have 7 values. So in this example, 21 is the total we get from adding all of our values, and divide that by the number of values, which is 7. The mean in this case is 3 days. The mean is the most common measure of central tendency. One of its advantages is that it's very easy to compute. It is used as the basis for a large proportion of statistical testing. A disadvantage of the mean is that it is sensitive to extreme values, or what we call outliers, that may really distort the representation of central tendency. The median is the midpoint or the center of the distribution of values, or the point above and below which 50% of the values fall. The median value is obtained by arranging the observations in ascending or descending order, and then determining the middle value. This may be the middle observation if there is an odd number of values, or a point halfway between the two middle values if there is an even number of values. To arrive at the median in an even number distribution, we add the two middle values together and divide those by 2. When the two middle values are the same number, the median is then that value. The mode is the third measure of central tendency and is the value that occurs most frequently in your data. In this sense, it is the value that is most typical. Its advantage is that it is the simplest of the measures of central tendency because it does not require any calculations. While the mode is very simple to use, there are disadvantages to using it. If we have a small number of values, each value could occur only once and there will be no mode. Or 2 values may be more common than others and you could have 2 or more modes. The choice of measure of central tendency really depends on the number of values that you have and the nature of their distribution. Occasionally, the mean, median, and mode are identical. For statistical analysis, however, the mean is preferable whenever possible because it includes information from all of the observations. However, if the series of values contains a few that are unusually high or unusually low, the median may represent the series better than the mean. The mode is often used in samples where the most typical value is preferred. Variability refers to the difference between each score and every other score. For example, if there are 100 scores, you would have to compute the difference between the first score and each of the 99 other scores, and then compute the difference between the second score and each of the remaining 98 scores, and so on. So there would be 4,950 differences in all. A more feasible approach, which serves the purpose just as well, is to define the differences or deviations for all the scores in terms of how far each is from the average or the mean. A range, that is the simplest measure of spread. It indicates the difference between the largest and the smallest values in our frequency distribution. It is the easiest to compute. It is the simplest order-based measure of spread, but it's far from optimal as a measure of variability for two reasons. First, as the sample size goes up, the range also tends to increase. Secondly, it is obviously affected by extreme values that are very different from other values in your data. The variance is a frequency distribution, and it's the average of the standard deviations from the mean. The symbol S2, listed here on your slide, is used to show the variation of a sample. The variation of a distribution is larger when the observations are widely spread. To calculate the variance, first determine the mean. Then the squared deviations from the mean are calculated by subtracting the mean from each value in the distribution. The difference between the two values is squared. That's listed here. The squared differences are then summed and divided by n minus 1. And you can see some abbreviations listed here. They are also on page 183 of your textbook. Standard deviation is the square root of the variance. As such, it can be more easily interpreted as a measure of variation. If the standard deviation is small, there is less dispersion around the mean. If the standard deviation is large, there is then a greater dispersion around the mean. To understand this concept of standard deviation, it is helpful to learn about what mathematicians call a normal distribution of data. That means that most of the values in the set of data are close to the average, and relatively few values tend to be one extreme or the other, creating a bell-shaped curve. Standard deviation is a statistic that tells how closely all observations are clustered around the mean. When the examples are closely gathered and the bell-shaped curve is steep, that means the standard deviation is small. When they are spread apart and the bell-shaped curve is relatively flat, that means the standard deviation is relatively large. Normal distribution means that if the variable of a particular characteristic for every member of the population was measured, the frequency distribution would display a normal pattern with most measurements near the center. It would also be possible to accurately describe the population with respect to a variable by calculating the mean, variance, and standard deviation of the values. Not all distributions are symmetrical or have that nice bell-shaped curve. Some curves are skewed. That is, their numbers do not fall in the middle, but rather at one end of the curve. Skewness is the horizontal stretching of a frequency distribution to one side or the other so that one tail is longer than the other. The direction of the skewness is on one side of the long tail. Thus, if the long tail is on the right, the curve is skewed. to the right. If the longer tail is on the left, that means the curve is skewed to the left. There are two figures in your textbook you should review for this example. Figures 10.3 and 10.4 in your textbook. Correlation is represented by the small letter R. It means the extent of a linear relationship between two variables and can be described as strong, moderate, weak, and negative or positive. A positive relationship between two variables is direct. A negative relationship is inverse. Correlation does not imply causation. Just because two variables are highly correlated, that does not mean that one caused the other. The value for correlation will always be between -1 and +1. A correlation of 0 means there's no relationship between the variables. The closer R is, or that correlation, is to -1 or +1, the stronger the relationship. The closer R is to 0, the weaker the relationship. -1 implies a perfect negative or inverse relationship, while +1 implies a perfectly positive or direct relationship. Chapter 10 shows 3 sample scatter diagrams that show a positive and negative relationship and one that shows no relationship. You can go ahead and skip ahead and look at those if you'd like, or wait till we get to the next lecture.